Good morning, aspirant. Hope you all are doing well. Your days are going productive and you are doing excellent in your studies. So we have understood the properties of operator, and based on that, I have said you that I will give you some questions. So you have understood the properties of commutator, something commutes or not. So let's write question number 1. Find the value of ddx, x. First, I will solve one or two questions with you, then I will be giving you. Find the value of this. What you understand with this? So this sign and two operators with a comma indicates that it is a basically commutator. Okay. So we will write it like this. We will solve it like this. First, write the commutator ddx, x. Whatever it be, ultimately it is some combination of operator, and every time operator operates on a function, independently operator has no sense. Operator doesn't make any sense independently. So it will operate on some function. Suppose my function is psi. Now we know if two operator is written like this, a comma b commutator, that means ab minus ba. So here suppose a is ddx, b is x. So what should we write? ddx of ab minus ba, right? ab minus ba. But independently, this is one set of operation. Here it is also one set of operation. Obviously there will be psi attached with it. Okay. Now here it is ddx of x psi. Suppose it is a multiplication, derivative of something uv, ddx of uv. That is basically x d psi dx plus psi d x dx minus x d psi dx. ddx of psi means d psi dx. dx dx cancel. So here it is x d psi dx minus x d psi dx, right? So this is also nullifies. Okay. So we are only getting psi into 1. That is basically psi. So we are writing like this. ddx x of psi equal to 1 into psi. You can write it like this. Fine. No problem. So what is the value of this part? 1. So we will be writing ddx comma x. Commutator, its value is 1. If the cross question arises, that the question, I have given a question like find the value of. If it says that does ddx, the another question can be framed like this. Does ddx and x commute? So then we will write it like this. Let's see what is the value of the commutator. The value of the commutator is 1. The value of commutator is 1, that is not equal to 0. That means doesn't commute. Does not commute. If the value of commutator becomes 0, then it commutes. But the value of commutator here is non-zero. That means it doesn't commute. Okay. Okay, so in the upcoming questions, you have to find the value of the operator, value of the uh, commutators, and we have to also say that will they commute or not. Okay, so let's go question number 2. Let's go to question number 2. Uh, Let me just write what we have got, the ddx comma x. The value of this is basically 1, right? Question number 2 is ddx of x square. What will be its value? Which property will be used here? Think very carefully. ddx, this is one operator, comma, x into x, two operators multiplication. Which property will be used? This property, distributivity. This property will be used. Okay. So there will be psi. No problem. First we will write x. Okay. Dx of x. Let me make it more clear to you. First, ignore psi. Let's just write how you can write this operator. First, I have said you write this one at the left and this one at the right. Then this plus this. Here you will write the first, suppose this x you have written, so you will write this ddx of x, ddx comma x. Here you will write ddx comma x, isn't it? ddx comma x. Here will be psi, here will be psi. Now x cap into ddx x minus x ddx. This is the meaning of the operator. This is the meaning of operator. AB minus BA, right? AB minus BA. Individually there will be psi plus ddx of x plus x ddx. And here will be x psi, right? Here x d psi dx, like uv, x d psi dx plus psi, dx by dx means 1, minus x d psi dx, no problem, plus ddx. This is basically dx means 1, so 1 into x psi, that means x psi, 1 into x psi plus x into ddx of x psi, isn't it? Now here we are getting x d psi dx minus x d psi dx, cancel out. We are getting just x psi, okay, x psi plus x psi plus x dx psi plus x psi into 1, right? Sorry. What's wrong? What's wrong? This is the problem. If we just, you know, let's say, this two are same operator. Okay, same operator x square. So you can write it ddx x square minus x square ddx. No problem. This is basically commutator. That means ddx of x square psi minus x square d psi dx. No problem. Now this we have to solve. Here also maybe I have made some mistake. Hmm. Hmm, 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 hmm. Okay, we will see later. Okay, maybe in this step. Okay. Okay, so now how will you solve this? First, take psi ddx of x square means 2x plus, let's take x square into ddx of psi means d psi dx minus x square d psi dx. This and this cancel out. So 2x psi. So ultimately we get d dx comma x square of psi equal to 2x psi. That means the value of d dx comma x square is basically 2x. Similarly, question number 3, you solve d dx of x cube, sorry, d dx comma x cube. You will get the same result like this, d dx of x cube. Are you getting some pattern? It is basically becoming like the differentiation. X square ka differentiation, that is 2x. For x cube it will be 3x square. Will it be 3x square? Let's see. I am solving another one for you. Question number 3, d dx comma x cube. D dx comma x cube psi equal to d dx of x cube minus x cube d dx. This is basically commutator means on psi, that is d dx of x cube psi minus x cube d psi dx. So first take out x cube, then it will be d psi dx plus, plus first we have taken x cube out, then we will be putting psi out into d dx of x cube means 3x square minus x cube d psi dx. This part is basically solving to this part. Okay, now minus x cube d psi dx plus x cube d psi dx, so 3x square into psi. So this into psi means 3x square into psi. That means this part means 3x square. This is nothing but 3x square. So commutator of ddx and x cube is basically 3x square. So question number 4, if I give you ddx of x to the power ddx comma x to the power n, this is an operator, then what will be your answer? Ultimately what will remain? This psi and psi will be cancelling out from two sides. This is basically first order differentiation of that function, isn't it? So it will be n x to the power n minus 1. So we are getting one formula, very important, you have to recall it. that operator of ddx operator, sorry, commutator of ddx operator and x to the power n operator results n x to the power n minus 1. Okay. Similarly, if you solve, suppose question number 5, I am giving you x to the power n operator comma ddx, what you will get? X to the power n. So let's try x to the power n ddx. Suppose there is a property of an operator that this means there is a property of an commutator that we have seen that AB minus BA, A comma B commutator means AB minus BA equal to minus BA minus AB minus BA minus AB, that means minus of B comma A, right? So we can write it like minus ddx comma x to the power n, isn't it? So ddx of x to the power n means nx n minus 1. So minus nx to the power n minus 1. Clear? Because what is this property called? Answer me. What is this property called? The property of asymmetry and antisymmetry. Asymmetry, you can call it asymmetry or antisymmetry. So this is due to antisymmetric property of the commutator. Okay. There are a few questions. We will be solving it later in the next class. So two important formulas we have seen today, that is ddx operator and x to the power n operator if they commute. If its commutator is written, that is nothing but nx to the power n minus 1, and if it is sorry bro, and if it is x to the power n operator, x to the power n operator comma ddx, it will be minus of nx to the power n minus 1. Okay. So these two very important formula we have derived with questions, isn't it? So in the next class we will be solving more. Till then, have a nice day.